So we are also back. So before we did the basic structure, and now we need to optimize the API. So let me set up something really quick. Okay, so right now you cannot see the screen because it contains some information that I don't want to share. So for now it will be only me describing the API while I write on my paper. So what we want to do in our API, as the first thing we need to play animation that is separate images for every frame, and this is the one we did. So play separate images. Now animation can be smaller and with transparent graphics. Okay, so we need a way to make animation occupy an arbitrary data. Okay, so we need some kind of preview area. Then it automatically centers smaller graphics, which means we need to center as the default behavior, center alignment. We need to be able to show text inside the animation screen, so display text. We have to make sure the animation screen cannot be closed until the animation is played at least once, and this is a behavior we already implemented, so it's a conditional close. Play time, play count greater than 1, greater or equal than 1. Okay. Then we can decide whether the animation is looped, played once, or multiple amount of time. So play type, it can be looped, it can be n times, or just once. The animation, okay, we need to be able to manipulate the time frame, so custom frequency. Okay. Okay, we have basically every the main details. So now we just have to design our API to make this work. Okay, so the first behavior, which is let's write them here. One, we need to be able our to-do list. One, we need to be able to play separate images. Done. Let me remove my autocomplete. Now we need to be able to handle preview area. We have not done this yet. Now we need to center alignment. Now we need to display text. And we have a conditional close, so right, conditional close, which is play count greater than or equals to 1. Play type can be looped n times or once. And then we have to be we need to be able to handle custom frequency. Okay, so this is our main objective. So let's create a component called Animator. Let's move our to-do here, and now we need to type animator struct. Okay, so for each one of these we need to make a method. So to play separate images, this is just some kind of load function. So we can say this is basically a constructor. So func new design for constructor. Let's think about them later. So no, actually you can do load from, I don't know, because load is already, but we can use load and change path. Okay, let me see an example here of how it's done. Okay, I see. So what we want to do is to be able to create a simple animation. So func simple animation. We definitely need file name, frames, loop, and frame rate. But since I don't want to make everything tied like this, so Animator, change file file name. Okay, so this is the first part. Preview area, we need to change the drawing rectangle. So Animator set draw rect, which geometry dot rectangle. Okay, now we need center alignment is part of this, but we can technically add other kinds of alignment. Display text, this is a bit more complex, so let's just keep it right here for now. Conditional case, this is embedded in the execution. Play type, okay. Play type, I think this should be at construction level, because it's before we actually animate. So when we create a simple animator, new simple animation, we have our play type. Let's call this mode, and custom frequency, we can change it here with another a animator change FPS. Okay, we have the basic API scheme. So now we can just see, we can first create the animator here. Okay. So right now we need a basic for methods, which is load count, load, unload, and destroy. So load count needs uint64. This is uint64 with error. This is uint64 with error, and this just as an error. So Animator is the component that handles an animation. So load count implements memory dot kernel. Load implements memory kernel. Load implements memory kernel. Destroy implements memory kernel. Okay, so if a is equal to nil, let's return 0, and let's return 0. If a is equal to nil, return 0, errors. Any receiver, return 1 nil. Okay. So let's nlock is the number of external components that have are still using this component. Nlock uint64. Now nlock a dot nlock, return nlock. Okay. Now nlock a dot nlock if nlock greater than memory max load count, return nlock memory excessive usage. If nlock greater than 1, 0, nlock equals nlock plus 1, animator nlock equals nlock, and return nlock. And now animator dot nlock equals 1. Unload, so nlock a dot nlock if nlock greater than 1, nlock equals nlock minus 1, animator dot unlock equals nlock, returns nlock nil. Otherwise we just set a dot nlock equals to 0. Destroy nlock equals dot nlock if nlock greater than 1, return memory r still in use, and then a dot nlock equals 0. Errors. still in use if the component is still mixed. Okay, now we have the basics memory management functions. Set row rectangle implements engine widget. Okay, this means everything here is not memory kernel, but is memory widget, engine widget. Now errors. Nil receiver if the receiver is nil. If A is equal to nil, return errors receiver, return nil, and now we need to work on rect. We need to render this function, so animator render engine the engine the renderer if A is equal to nil or the error is equal to nil, do nothing. Render implements widget. Now animator draw rect geometry rect okay, and everything here is after the constructor. For now we need the area, so rect is the draw rectangle of the component. So we load, we unload and destroy dot rect equal nil. Set row rectangle, so dot rect equals rect. Render, so we get the area if k rect is empty, we don't render anything. Through rect we just return a rectangle. And now we construct here our animator. Okay. We take we need a way to advance to the next frame. all the files. We can just take the code from here. I need all of these. So when we change file name, we want to no, let's just root is the okay. So change file name equals this new file name string a dot file name, no, a dot root plus file name. Let me re-enable for the comments. Okay, we have set the new file name. We may want to load everything here. Okay, because this load function actually just loads the data that is at the first call, but we cannot change. Okay, we cannot change dynamically. So this file name is actually part of the constructor mode. For now, just let me see everything here that we did not allocate. There is a constructor. Okay, so we have rect nil unlock 0 root equals file name, file names nil, number of files 0, surfaces and textures. Okay, we can copy code from here. We need to, for now it's not important to split this code, so we can just take it from here. Still, I think this would be a good place to create an helper function. Load the PNG files, which is everything here. Dir name, which is the name of the directory. Now we need to store, the file name is here, the size and an error. And now we can do if est is equal to nil, errors, new nil parameters, est, okay, 0 est, entries. File names and number of files are short, longer. So for each entries, we do the check. We avoid recursing into subdirectory. We get the name, we get the extension, we ignore everything that is not PNG. Now we check. So if it's longer, let's put longer true and break from this loop. Let's create full path and let's append the result here. Now we need to store the result here and return, okay, if longer, else return number of files, slice r size exceed, return number of files nil. Perfect. Now we have to the directory storing the result back in the provided memory location without any side effects. If there are more than my .png files, the directory, the result may be truncated. Parameters, monitor to directory to read PNG files. The number of PNG files is never greater than 5 messages, and error if loading the PNG files fails. Okay. Errors is not main parameter, it's bar parameter. Switch error, not actually. If error is not equal nil, okay. Errors is error OS error not exist. If not okay, if okay, start tst equals nil, return 0 nil, else return 0 error. Okay, so let me okay. Okay, we have everything here. Now in our animator we just need to call that function with our file name, so root a dot root load the png files, our file names. Now we need to enter file names, root, number of files, and error. Now we need to switch this error, case nil, do nothing, case slice r size exceed. We need to warn the user that some result may be truncated, so lsl print log write log os sdd out prefix asl and format. Let's say that the result may be truncated. Default return 0 error. Okay. Like I don't even have too many viewers and I already need to ban someone. Okay. Now we have number of files. Okay, so if and we need to store this value somewhere. So if number of files is equal to 0, does nothing. So a dot file names equals nil, a dot number of files is equal to 0, and return 1 nil, a dot number of location 1. Otherwise, just do everything as before. I need to change this later. Let me make a fix me adapt the window ID. Okay, now we can just call a m dot a. If a is equal to nil, it means we errors, no, it's memory illegal access, or illegal access, error a dot load while loading animator return 0 error. Otherwise have m.a m.unlock is equal to 1. No, because we already have that, and this is a pointer, but just for measure I will put it. Now this unload function okay, no need to check nils, and number of unlocks needs to stay here. Okay, and now the same thing but with the destroy function. So we have file names, texture and stuff like this. This is not needed. This is here, 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 here. Width and height are not part of this. Index, delay and play count are somewhere else. Texture, okay. Set rect, render, animator, and everything is set. Now we can just take the animator. Everything here is not needed. And then destroy. Okay. Set size. Okay, now now that we have this, we can create a new rectangle. So geometry, new frect, c rect, frect, yes, 0 0 with height. And now we need to take the animator. If a is equal to nil, it means not this error. Memory illegal access. If the module has been destroyed. Okay. Now we need to set draw rect, a pointer to rect. If r does not equals nil, we're setting animators rect. Okay. Update handle key render. Okay. So now we need to copy this render function. Okay. A.texture, A.index, errors not nil. We don't need this because we already have rectangles. Okay, now we need the index and delay. So load, yes, sure, unload, sure, destroy, we need these values. Play count, a dot delay is equal to 0, a dot index is equal to 0, a dot play count is equal to 0. We can copy these values here. And render is everything here, okay. Index play count is equal to 0, yes. A number of files, index, index as loop, sure. And now we can just take m.a, a.render, and we pass virtual renderer. Now we need to create new simple animation. We said that it's assets, Brain A ship, move left, mode 0. If r errors new not nil, and now we have a here. Okay, we don't need these anymore because we have anim. Okay, load count. Okay, unload set size. Okay. Okay, now we need this function. Let's call it update. Okay, this is something we need to change later. Okay, so let's see our to-do list. Actually, let me implement this. anim.mg.anim if anim is equal to nil, return memory legal access. Now we need to get the play count. No, actually no. We can transform this into a signal. For now, who cares? Let's do the standard thing and return everything that can be returned. That makes sense to return. So direct already unlock already root. Okay. Animator file name string face equal to nil. Return empty file names, otherwise root a dot root return root. Okay. Actually no, because if we load because loading does not but later loading may require access to the game engine, so it's not something we can do right now. unless for now let's ignore this. So returns name of the animations group directory if the receiver is nil. No, file name is return. Okay. For this is a bit awkward to return this for now. Index, okay. The only one that makes sense is play count. Okay, now we can get Animator, g.animator, return errors, no, not errors, memory, illegal access, anim.playCount. Okay, perfect. Let me generate okay, it does not work. What I forgot, maybe in update, let me check everything. Okay, because I don't have actually loaded the files. It should not give me an error. But yeah, but I don't need them here. I can just put them out. File names, number of files, index play count is equal 0, number of locks, okay. Surface is texture, file names, number of files, delay play count and index, unload, file name sure, destroy sure. Okay. Okay, now it works. As you can see, the boat moves properly. Now, let me see the rest of my to-dos. Okay, handle preview, center alignment. Okay, so we don't have stretching. Nice. Each frames can be different, so we need the draw reds over every single texture. So sources is the list of source rectangles. No, this is ASL rector. So sources. I can also split destinations. No, but we need stretching though. Okay, so now let me remove these comments. Okay, we need to change this value, which is inside here. So max delay between frames. Let's uncap it. No, but in 16 I think is a good value. Max delay. Okay. Change FDS, no. Change delay. except test, we done everything else. Yeah, we need just to delete a dot max delay is equal to 0, and now in the max delay is equal to 1. Okay, let me read the specs. Okay, now the next phase is to create I don't know if I want to use sprites. It could create problems. However, we could create this object and only use it like a backend of some kind. Let me think. So if we have so we could not access to this item directly, but to use some kind of memory management system, which basically but we only need one, technically speaking, unless we want to do multiple cutscenes at the same time. So we could have a memory management system similar to how the music buffer works, music subsystem work. After we allocate this entity, and then we access to it for some. Okay, sure, this can work. I don't know if this is the approach I want to go with. Yeah, because then I also need to yeah, sure, why not? I just need to create some kind of layering system. But layering system technically only works within the render method, not the actual rendering pipeline. Okay. So we could do something like this. Okay. So let's create some kind of memory. Now we need anim manager, which has ASL, not memory manager, and ASL manager, and this is to have the animator component. Okay. Okay, so we need to allocate to the okay, we need to deallocate and we need to access. Okay, so once we start the animation, it goes by itself. Perfect. So instead of just allocating, we can do some kind of no. For now, let's keep it simple. Allocate animator. So animator, give it an ID, and an error. If anim is equal to nil, we cannot allocate this. No, actually, yeah, we can allocate an elements if we want to start it later. So Animator dot allocate animator, we get an ID and an error, right? Is it true? Yep. If error, okay. Okay, now instead of having this animator in memory, we actually have it in our allocator. Yeah, but this means we still have the animation, just the ID. So allocate animation, anim, ID, R. If R is not equals nil, panic, yeah. Anim, let's just anim ID. Okay, now we need to load this. Load it. Okay. I don't know if I want to do it here. This component should not be responsible of. Okay, for now, let's do manual control. We have a get method. Okay, yeah. Okay, this means we don't actually need the API for, no, but let's keep it. Get animator. Okay, unload. We just need anim ID, mg anim ID, mg anim ID is equals to memory invalid ID. Okay, perfect. And now we need to get the animator. Get animator anim ID. If it's okay, if not okay, return nil. No. If okay, we need to unload it. Destroy, same thing. We have animator ID, anim ID. Anim ID is equal to invalid ID. We get the animator. If okay, and let's destroy. Same thing here. Anim ID. Let's get the ID. Let's get this animator. If it's okay, we set the direct, which is this one. Update, okay, same thing. We need animator ID, okay. Get animator, anim ID. If it's okay, we want to update it. Under keyboard, same thing. Nothing new here. Anim, okay. Get animator. If it's okay, we get a play count and we panic otherwise. Render, same thing. Anim ID. Okay. Get animator. I freaking hate this autocompiler sometimes. Okay. Let's do a quick check to see if everything works. Yeah, everything works. Now we need to export this functionality. Okay, these are just one-time runners. Okay, so let's create options. So type animator options. Type animator settings. Okay, now we can take the animator and move it here. We can rename this package as pkg. Let's see, what are these options? So when we allocate, so this function actually goes inside the memory allocator. So instead of allocating custom, we actually created one ourselves. And we only pass the file name. Okay, and now we pass the options. So settings, animator settings with the default values, we range from options. If option is equal to return 0 of nil, animator setting, settings, and now we can apply the settings. Okay. 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 Now memory. Every time we get this animator, we actually need to destroy the object itself. We need to access this. Okay, let's see where we use it. Load. Okay, so load only applies the first time we run this element. So we create a new function, play So it works in this way. We have Animator, we get the one with this ID, so is good. If not okay, return memory, no such ID. Now we need to load this value, anim.load if r not equals nil, r play the animation and return. Okay. So now we need to play Animator or animation ID. Now unload this can be done manually or once it is done. So we create a new function called stop animation. Which is similar to this one. Let's just call it display. And stop. Unload. Stop the animation. Okay, so it basically works like this. When we call the method stop, we say the function, we say the animator. Okay, so animator can only be loaded one time. So analogs, we don't need this one. We need is loaded indicates whether the animation is loaded. So is loaded. Yeah, but we need a different way of loading this thing because it's not an object, a widget. First of all, it doesn't even have the unload, so it doesn't make actual sense to have this as something. So let's remove the entire loading mechanism, since this does not apply anymore, and everything here needs to go inside the memory system. Basically, we have root, which is file name, okay, result may be truncated, animator, we have everything here, file name, number of files, delay, index, okay. Now, if there are no... Okay, but this is a problem because it's an empty file, there are no frames. So this is technically an error. So let's warn. If number of files is equal to 0, errors. Okay. Which means this case does not exist anymore. Which means this one can be moved over here. Which means this can be put here. Okay, and now we allocate this entity. Play the animation. We need a way to signal that animation should be played. Okay. Unload, same thing, but this time we don't want just unload, but the basic destroy method, which needs to exist for the memory management unit to actually do something. So we just destroy. Okay, so instead of Anim Manager, deallocate ID error return error. Nice. Okay. Stop. Nice. And now update. This needs to be bound with the physics engine. What we don't need in our animator this time. Root. And technically file names. So let's remove these from the system. So when we okay, now we need the settings. So the first set, no, actually no, because we need to start the animation system. So to start it, we need to know, no, but yeah, only when it's not started. So is playing. So now when we call the play method, let's check. So if it's not okay or the animation is equal to nil, do this anim dot is playing. If it's playing, r ready playing, and if not, animation is playing true. Nice. So not so the only error we return is of type errors.new. Damn it. If the animator is already playing, and if anim is equal to nil, so we take this animation, so is playing. So if it's not playing, do nothing. Otherwise, we need uh, to inform the animator to stop playing. And we know that if it hasn't started, we can just stop it. So we can just terminate it. Okay. So anim is playing equals false, and now we need to stop the actual thing, which means we need our no, actually we need a thread right now because we need to send a signal. Okay, this is fantastic. So let's create a DOM channel, make chance struct, defer close down, and then down we send a signal, and then we receive a signal from down. Okay. Because we need to wait for this animation to end. Exactly how we do this is something left in air. Until then, I need to update the system, which is not something on individual animators, but global. So we can just say update, which updates every single animation in the manager. So all sequence if r assert sec for each animator range sequence if r as errors not nil, the animator, okay, animator update, we get the error. If error does not equals nil, error, we return an error. Otherwise, we return nil. This can technically be to do. This can be turned into concurrent coroutine. Yes. So now, instead of updating this one, mg update every single entity. Since this is the only thing we need, return error. Stop this animation. Okay, render. We need to render everything, so like we did before. um, um, okay, so when we get set size, we need to specify the exact value for this. Okay, so we can just say when we want to play this. No, but okay, we can just do the simple thing, which is change draw rect id geometry rectangle. Perfect. pkg change draw rectangle of animation id with this exact rectangle. Okay, we need to destroy this thing, but that is a game engine level. So we can just release everything. Quit, which is quit the system, and Animator dot release error return error. Quit. Okay, no, we need to quit after stopping everything, or rather quit, stop every single animations according to the rule. Quite interesting, to be honest. So this is something I need to check, which basically before releasing everything, we just need to quit all. So stop all, which basically sequence the every single manager. Okay. Now, how to stop this thing? Basically, when we stop, when we actually ask to stop this, I think this is the most complex thing I have here, which at every single for every tick we need to for each tick, so we need to access our, what is it? We need a way for this update function to also signal. Okay, so when we stop this animation, we have to check whether hmm, okay, the base operation we need to do is if the animation is not playing, there is nothing to do. But if it's playing, then we need to set is playing to false, and then we can do this. However, we get the animation play count. If play count is equal to 0, then we cannot play. Otherwise, we can just quit. So now we need to wait for the animator to stop. Okay, this means the animator must be mutex blocked. So the mutex for the components, sync read write mutex. Okay, destroy requires to lock the mutex, set direct lock mutex, render read and write lock. Okay, direct read and write lock, change delay lock and lock, next frame lock and lock, and update lock and lock. Perfect. Okay, now we need to get the play count. So func a animator play count doing 16, read and write. Okay, play count, return play count. If resident nil, no, play count is return. Okay, now we have to get the play count. So count equals actually PC equals animation play count. If PC is equal to 0, wait, else do something. This means we need a for loop here, and if PC divided by is not 0, break. Okay, and now we need to wait to do find a way to put an upper limit on this loop. Okay, now this needs to be sync-threaded with the update function, which is something we can make here. So when we want to play this animation, we just create a new function. So a new thread function. Wait a second. Okay, we need to create a new function called start. No, not start. Init, which starts a go routine. This go routine requires us to we need to be able to send signals here. If we can send the signals, we need a signal channel. So call Q is the call Q for the animator, which is nil. When we want to, yeah, but I need to design this a little bit better. Okay, so now we have 4, because to do find a way to put an upper limit on this loop. We need to this requires okay, we can send a signal that this can be start and stop or change. So we get a function. So we have we need to create a call queue, yeah, but this time is a function. I know we can just use a channel chan. We get that gets a function. So when we start this new, we can create a channel function. Okay, so not close call queue, call in main func, okay, which is for now is nil. So we create this, we define a new call in main function, we takes a function, go to call queue, not really, what this yeah, just forwards the value. If f is equal to nil, does nothing, and forward this value. Or it's no, it's better if we actually inside here. Now we need channel done, which needs close. Once we send this and we lock, perfect. For now, let's keep this nil. We don't care. Once we are done, call in main is equal to nil. Now we need to we have two signal, which is select case function call q function nil, and should technically not be nil. So let's break from this. Exit equal true. Var exit boolean if not exit, and we run this function, and we have the we need to add add the timer. Okay, so okay, now how we can actually send signals here. So we have a function that is run inside here, and however this function always have to operate on a single animation manager, which means we need an ID. Now we have an ID. Okay, so we have a function that takes an ID. What this function actually? Okay, okay. No, no, this is completely wrong. Okay, so basically, mm, okay, it's getting a bit late. Need to do few things. Okay, I mean, we are in a really good position for now. We just need, I just need to find a way to integrate this subsystem in the game engine, which is, which will take me 5 hours. I don't think today I have the time to do it. uh, I need to change to think about the new architecture, which will be a problem of in itself, but that's beside the point. And yeah, and after that I think I'm done. This actually gives me an idea to how to create, how to structure new plugins, because this won't be this last one, the last plugin I need with a similar API mechanism. So I think let me add it in my to-do list. Um, where is my pen? Damn it! I always lose my frick my pen. I used it before. Okay, it's here. Okay, so I need to find a generalized system. Okay, so a generalized API system and subsystem. So a generalized API system and subsystem for plugin integration. Okay, so I think I have everything laid out. I will think about an interesting structure. This is something I don't do on live, because otherwise you will be just staring at a black screen for hours, because during this phase I don't actually code. So so for now I will stop. Later today I will code. I will finish coding my SLP. Okay, so for now it's all.